This video, we're going to talk about the remaining application problems for the law of sines. I've already solved the problems out here to the correct number of decimal places, and I'm just going to show you how to draw the picture to set it up and solve it with a calculator. So we have a ship that's traveling parallel to our shoreline. I've got a lighthouse that is going to be out here. And we're going to take two sightings of the lighthouse. It's out here. The first sighting is that this angle is 12 degrees. The second sighting is that the angle is 23 degrees, and we've traveled 5 miles between these two sightings. Because this is a 180-degree angle, 180 minus 23 degrees is going to give us 157 there, and 157 plus 12 is 169. 180 minus 169 is 11 degrees for this angle from the lighthouse between the two positions that we were at. And I want to find this distance from the second position to the lighthouse here. So that's going to be across from 12 degrees. And I have the 5 miles is across from the 11 degrees, and I use the law of sines. X is equal to 5 sine of 12 over sine of 11. And we get 5 sine of 12 divided by sine of 11 is 5.45 miles, approximately. Now we have a similar problem here with a rocket that's taking off. So this is vertical position here. So here's my rocket. And there's going to be two stations A and B that are to its east here. The stations have a distance of 2.5 miles apart. And let's see which one is closer. The closer one has the bigger angle. Station B is here and has an angle of elevation of 40 degrees. Angle A is here and has an angle of elevation of 26 degrees. And we want to know the distance that the rocket is from telescope B, which is actually going to be little a, since it's across from angle A. That'll be the distance from the rocket to B. So A is to sine of 26 degrees as 2.5 miles is to, and I need to figure out these angles here. 140, so this is 166, making this 14. I'm sorry about that. That was some bad handwriting on my part. Let's come back and re-enter this. That's where I'm getting 14 from. And 4.53 miles. There you go. Again, Sorry for the typo. There we go. Guide wire to the top of the tower makes an angle of 70 degrees with the ground. Then there's going to be an observer that's going to stand 27 feet further away. And he looks at the top of the tower. He has a 27-degree angle. We want to know the length of the guide wire here. I'm going to call the height of the tower H. The distance here I'm going to call X, so that tan 70 degrees is H over X. So X tan 70 degrees is equal to H. And then I have X plus 27 for my base there. And my height is the same. And this is going to be tangent of 27 degrees. So X tan 27 plus 27 tan 27 is equal to H, which is equal to X tan of 70. So 27 tan 27 is equal to X of tan 70 minus tan 27. We're going to divide. So the X equals 27 tan 27 divided by tan 70 minus tan 27 gives me an X that's about 6.1472218. Now I'm going to use the Pythagorean theorem here in just a second. Once I find H is, let's call this X. So the square root of X squared, which is this base squared, plus this height is X times tan of 70. X times tan of 70. That's squared. That's all inside of a square root sign is going to give me my length of 17.97 feet for the guy wire. Now we have ships at sea. We've got point A is going to represent the admiral, and point B and point C is somewhere out here. And this measurement is 45 degrees between the Barstow and the Caudru from the perspective of the admiral. And they compute that the distance between the Barstow and the admiral is 323 meters. Barstow reports an angle of 59 degrees between the admiral and the Caudru that wants to then know to the nearest distance, the distance between the Barstow and the Caldrew. We have these angles 45 plus 59 gives us 104, 180 minus 104 is going to give us 76 degrees. So 323 over sine 76, x over sine of 45. So x is equal to 323 sine 45 over sine 76. That's going to give us, to the nearest meter, 235 meters. This next one's a little tricky because you're on a slope. So there's a slope of a hill that is 10 degrees from horizontal. And you've got a flagpole here that is vertical to the horizon, not to the hill. And the sun is going to cast a shadow onto the hill here, and that angle of elevation there from the slope from the hill there, looking up at the sun, is 36 degrees. Because of the 10-degree slope here, this is 10 degrees from being perpendicular. So this is actually 100 degrees here. And then it says that the shadow that was cast was 43 feet long. So let's go ahead and let's just pull that triangle out. It looks something like so, where this side is 43 feet. This angle is 100 degrees. This is 36 degrees. And that means that we have 36 plus 100 is 136, and 180 minus 136 gives us an angle up here of 44 degrees. And we're going to use the law of sines to say 43 over sine of 44. We want to know the height of the pole, which is this side, over sine of 36. X equals 43 sine 36 over sine 44. And we want to calculate to the nearest tenth of a foot. So that's 36 4/10 feet when we round to the nearest tenth. And that's it for this video. So we'll go ahead and cut it there. See you next time for the law of cosines.